Gosh darn it, this homework is so stupid. How am I supposed to find the missing side length of a triangle when all I have is the other two sides? There's got to be an easier way.
Did someone say right triangle? Have I got the product for you, little Timmy?
My name's Billy.
This product is guaranteed to work for any right triangle you throw its way. From big to small, from missing hypotenuse to missing leg, this product is guaranteed to work for any missing side length in a right triangle.
Well, what is this miracle product you speak so highly of?
Well, Timmy, it's the Pythagorean theorem, of course.
The Pythagorean theorem?
Yes, Timmy, the Pythagorean theorem. And for 5 simple payments of $19.99 US, this product could be all yours for all of your homework needs.
Well, where did this miracle product come from?
I'm glad you asked, little Timmy.
It's Billy.
Well, you see, Timmy, this theorem was published by the ancient Greek philosopher Pythagoras. Though it was theorized that many philosophers worked with this theorem before Pythagoras, it was Pythagoras that gave us the formula for finding the missing side length of any right triangle based on the other two side lengths.
And what just happens to be this miracle formula?
Why, it's a squared plus b squared equals c squared. Of course.
What kind of alphabet soup formula is that?
Well, let me explain. The Pythagorean theorem states that you can find the square of the hypotenuse by finding the sum of the other two sides squared. So, if we have a right triangle with sides A, B, and C, the Pythagorean theorem states that we can find c squared by taking the sum of the other two sides squared.
You said this works on any right triangle?
Yes, any right triangle.
Really? Any right triangle?
I promise, Timmy, this theorem works for any right triangle you throw its way.
Well, what if I have a triangle with side lengths of 6 and 8? Would it work then?
Look, Timmy, what part of any right triangle do you not understand?
Well, prove it.
You said 6 and 8? Okay. Well, first, let's draw our triangle. We know our side lengths of 6 and 8 are A and B, so we're looking to solve for C. So we have A squared plus B squared equals C squared. But we know that A and B are our side lengths, so that we can replace those with 6 squared plus 8 squared equals C squared. To solve for C, we need to take the square root of both sides. If you take the square root of a number that is squared, you get back the original number, or in this case, C. So we'll take the square root of both sides. We end up with the square root of 6 squared plus 8 squared equals C.
And that happens to be...
So because we know that C is equal to the square root of 6 squared plus 8 squared, we can simplify from here. 6 squared happens to be 36. 8 squared happens to be 64. So we're looking for the square root of that sum to equal C, or our hypotenuse. 36 plus 64 is 100. So C is equal to the square root of 100, which happens to be 10.
That's a pretty neat trick there, mister. But what about in the case of having the hypotenuse and one of the legs, and I have to find the other leg? Does your precious Pythagorean theorem work then?
Like I keep saying, kid, this theorem works for any right triangle you throw its way.
Well, I bet it can't be used to solve for when the hypotenuse is 13 and one of my leg lengths is 5.
You bet your sweet bippy it can. All we have to do is rearrange our general formula. First, let's draw our new triangle. In this case, we'll make A 5, B, C 13, and in this case we'll be solving for B. In order to isolate B in our general equation, we have to subtract A squared from both sides, giving us that B squared is equal to C squared minus A squared. Similar to solving for C, we need to take the square root of both sides. So the square root of B squared and the square root of C squared minus A squared. Square root of B squared is B, and that would equal the square root of C squared minus A squared. Well, we know that C is 13 and A is 5, so B is equal to the square root of 13 squared minus 5 squared.
Again, dude, I'm no human calculator like you. That just happens to be...
Well, 13 squared is 169, and 5 squared is 25. So B is equal to the square root of 169 minus 25. Well, the square root of 169 minus 25 happens to be the square root of 144. So B is equal to the square root of 144, which happens to be 12. So the other side length in our triangle would be 12.
Gee, you sure are smart, mister.
Well, thanks, kid. So what do you say? Can I put you down for an order of the Pythagorean theorem for only 5 payments of $19.99?
You know, I would, but you already helped me finish my homework, so I think I'll pass.
Gosh darn it, this is the 3rd time this week. Too much promoting, not enough selling. I'm never going to be employee of the month.
You know, thanks for the help, though. You know, you really should consider a career change. Have you ever thought of teaching?